Hello, everyone. Welcome to MATHurdays. Math's so fun. We do it on Saturdays. I'm Teresa Wills. I am so excited to walk us through a math routine and rich task that you can use in your classroom, whether you're doing it in a virtual setting, hybrid, concurrent, flex, there's a lot of names for it, or you're just in person. So as we get started, let me make sure you all have the link to today's slides. It is in your chat box there, and welcome. On the second slide there, I have ways that you can get in touch with me if you have questions and more. I love talking about this kind of stuff, so send your questions to me. And on slide 3, if you want to head on down there, these are just templates and other MATHurdays tasks. So if you've seen it here in this in MATHurdays, I've got a bank of them online where you can get the blank templates, the completed ones, and a recording of the PD. And let's see what successes and celebrations we have. Come on down to either slide 4 or 5. And you're going to express yourself your way. Feel free to use text boxes, images, GIFs, pictures, videos, and more to tell us kind of what's going on. Oh my goodness. And my big excitement is, as of Tuesday, I'm fully vaxxed 2 weeks afterwards. So I went out to the store for the first time, and I'm going to be taking a trip down to Florida to visit my family. And since we're still not doing hotels, I got 2 littles with us, we're going to be camping in the Tesla. So that'll be fun. It's totally a thing. Like, you can actually turn on the air conditioning all night because it's electric and it doesn't have exhaust. So it'll be an experience for sure. All right, so let's see, what are your successes and celebrations? And let's hear about this adorable newborn. Oh my goodness. So sweet. And as we're all, googly-eyesing over this, who is in finals week? Is this at the university or is this in high school?
Yeah, community college.
Ah, very cool. So Raha, you are back 4 days a week? The kids are 4 days a week, is that right?
Hi, Teresa. Yes, they're 4 days a week. And I teach SPED inclusion, so I have a lot of my SPED students in the classroom, so it's really nice to work with them. Just having kids in person is really nice.
Yeah, I know we've missed them big time. And Laura, what a cool notice and wonder that you did with your teacher appreciation gift. I'm going to make it a little bit bigger so we can see on slide 5. Tell us about it.
Buenos dias. Good morning, Teresa. One of my students who is in person brought me a box of macaroons for teacher appreciation. And being the math teacher that I am, I couldn't just eat them. I had to take a picture of them and turn it into a notice and wonder, which my kids really enjoyed because then it was a gift for everybody. It wasn't just for me. The whole class got to enjoy it.
Oh my gosh, that's amazing and delicious sounding. So I think I know who it is, but I don't want to ruin the surprise here. Who's the one who put our picture of our little newborn there? Tell us, what are you up to these days? And let's see.
Hey, this is Cynthia.
Hi, Cynthia.
How you doing? Well, he came into the world on Earth Day,
Oh,
And what a blessing. The same statistics as his brother. So it's two little boys. What is the expression? There's a special place in heaven for the mother of two little boys.
no.
I love little boys. I love little boys. So we've just really enjoyed that. I have been working this week. Our schools are 5 days a week. The ones that I consult with, they're 5 days a week. So it's been
Wow.
great.
Well, what a cutie. I love pictures. Some of my favorite parts about this. Um, All right, folks, there's so many wonderful things that we can see on here. Thank you for the images, for the check-ins as our community, grows. And if this is your first MATHurdays, welcome. This is a community where we are very inclusive of everyone when they want to join, whenever you can. And we're going to jump right into our math routine. So that's on slide 6. It's called Always, Sometimes, Never, and there's a great little blog about it there, so you've got your link. And today we're going to think about probability and what students need to learn about probability. And so if you join me on slide 7, you are going to take a little bag there and you're going to create your own bag full of marbles. I've got some little circles off to the side, but if you're familiar with the circle tool, go ahead and use that and use the color in it. And this prompt is create a bag where the probability of selecting a red marble is sometimes possible.
Oops.
So right now I've just got a bunch of kind of empty bags, and as adult learners, you all are in here just kind of picking your bag, and when you see someone selected, you kind of know it's theirs. That will allow for anonymity. But with students, you might have initials or a little character or a number in it so that they know that bag is theirs.
How'd you get the bag in?
And then I'll have a couple questions for us. This one here, I'm going to put a big, bright pink arrow at it. You have the most colors so far, I think. Tell us, why does this still fit our rule that selecting a red marble is sometimes possible?
Good morning, Teresa. I wanted to have 4 colors. I don't know why, but I figured that as long as one of the colors is red, then the possibility of me pulling a red is still there, but it's not as high since I have 2 blues, 3 yellows, 2 greens, and 1 red.
Ah, I see. So we can have lots of colors and it is still possible. Of all of these, I wonder which is the least likely that we would select a red. If you think it's you, if you think you're least likely to select a red, let us know why you think it.
The least likely would be the one you're still pointing at.
I
Yeah.
think so too. I'm looking at mine. I'm counting the number of marbles. So far I have 8 and only have 1 marble that's red. So 1 out of 8 chances. And I'm looking at other ones, and the ones I was counting, I counted 8 marbles, but they have 2 or more red marbles.
Ah. And then another one of my favorite questions is, so here in the purple or the pink arrow, we have 2 red marbles. But in this one over here, we have 3 red marbles. And I would love to kind of ask, like, which one would have a greater probability, and how do you know, kind of getting that idea of ratio versus exact number out. But I love this because everyone gets to create their own. So it's not like you just have the one that we all look at. And we're all analyzing here. We could ask other questions. Just to kind of continue with our routine, I have 2 more. Since this is called Always, Sometimes, Never, you're going to see all of them. And so feel free to work on slide 8 or 9 at any time. I'm going to keep switching between them. Slide 8 says the probability of selecting a red marble is never possible. What would that look like? And then we could even ask our same question. Which one is more likely or least likely to pull out a red? And I'm sure you can see kind of the way that questioning would go. And we got one more on slide 9. I see some people are already headed down there. This is creating a bag where the probability of selecting red marble is always certain. And I love that I'm seeing people kind of copy and paste their old bags. And so we get to see the same like collection of marbles, and all that's changing are the colors. All right, I would love to put someone in the highlight here. This bag, I love this one. If you are the pink, whoops, cancel that. If you're the pink arrow here, tell us, why is this only has 1 marble in it? How is this a situation where it's certain that it will be red?
It's the only one you can pick. So you're stuck. That's it.
And Stacy, if you were to give this a probability of percentage, what percentage would you say is the probability of getting it red?
100%.
100%. So how about this one over here? If that's you, what is your percentage of getting a red? And if that is you, I invite you to turn on your microphone, but you're never required.
Sorry, Teresa, I got distracted.
Oh, no worries.
It is still 100% because I have 8 marbles, and out of the 8, I still have 8 that are red. So I'm definitely going to get a red marble.
Neat. And in our probability unit, we've also learned, instead of just percentages, that we could write this as a fraction or a ratio of, part reds out of whole. Let's use the chat box, a quick check for understanding. What would be the fractional representation of selecting a red marble in your bag? And this is one of my favorite ones because instead of me as a teacher explaining that, now they have so many examples on there, and that concept is more clear to them. So this was an Always, Sometimes, Never. The idea is that the students themselves are the creators of it. All I do is come up with a template and a question, and then they come in. Sometimes I'll even have my students be the ones to make the titles up at the top too. So awesome. All right, folks, let's jump into our task. We are talking probability today. On slide 10 are the reasons why I always do a rich task in my math. I love them because it lets me do all 8 of these math teaching practices each and every class. It's not just like today's the representation day. It's like, no, we're doing all 8 of these every single time we get together. So On slide 11, I would like to give you all the opportunity to be problem solvers today. I'm going to read this oath out loud. Feel free to read it to yourself. And if this is an oath you'd like to take, put your name down there in the chat box. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. Again, if you would like to take that pledge, feel free to put your name in the chat box. And so today I've got a little video for us to watch. Curious if any of you all are familiar with Plinko. It's kind of a fantastic game. We've got here a little video. Let me turn it up. And if you have your video on, give me a thumbs up if you can hear it. Awesome. Great. All right, here we go.
One chip at a time. Put him against the wall. Drop it. 10,000 right in the middle. Good luck, man. 5 chips.
Here we go, guys.
Go win some money. Here comes chip number 1. 10,000 in the middle. 10,000 in the middle.
Oh my God!
$10,000.
Oh my God! Oh my God! Oh!
Get another one. Do it again.
At any time, feel free to turn on your mic and say what you think the probability of him doing that
Same
again
spot.
is.
$1,000.
Yeah!
Got $11,000 so far.
Oh my gosh.
Oh, what was the chasing of that happening?
Oh my God!
21 grand.
Oh my God!
And he still has 2 chips.
Ryan! Ryan! Ryan!
Killing the game. Here we go. $10,000. Come back. 500 bucks.
Yeah!
21,500. Here's his last
Number
chip.
5! Number 5! Number 5!
Drops it right on the end. Good luck. 30,000.
Oh my God!
31,500.
Oh my God!
That was great. You
Oh
put
my God!
31,500 bucks.
Yes! Oh my God!
That's what you call a Plinko win right there.
All right, so now you all have some background knowledge on Plinko. It can be a very exciting game. And our problem is a little tiny bit different. We're going to look at the more of like a triangular pattern instead of a rectangular slot. So you can see kind of what our pattern looks like. Today, what I have for you is a Plinko generator. And so on slide 13, you can get a picture of like what this little generator looks like. But even this one is a little different from our problem. And I'll let you all discuss that in your group. Each group will have a set of slides where you're going to think about the way the Plinko chip would fall down. So for example, on slide 14, I'm making this one fall into prize 1, or does it fall into prize 2, or does it fall into prize 3? After you're done kind of examining this first slide, the next couple slides will increase the paths that it could go down. The final one, you are going to think about the prize amounts that should be in the bottom. So use your knowledge of Plinko, probability, and game shows to design your own results for the bottom. All right, folks, we are going to start breakout rooms. Slide 14 is where group 1 starts. Slide 18 is where group 2 starts. And there's a little color code on there to support you with finding your room. I hope you enjoy this and use the simulator if you like, or just draw right on it. Love to see the representations you get. So here we go. Here are our breakout rooms. You should be able to click in them at any time now.
show, I guess. I watched Jeopardy. That's the game show I watched.
That's from Price is Right.
Oh, okay.
It's from Price is Right. And
Got
I've
it.
seen the game before, but I haven't seen that particular one because I've never seen anybody win Plinko.
13, I think it's just to let us know, because I don't know where is the link that we can try this out.
The link is in slide 14, but I don't see why we
Oh.
would need it to do the probability of 3 different prizes unless,
Oh,
because that's,
I see. So how should we approach this?
I would say the probability is 1/3 for each prize, I guess. But I don't know, like I said, I don't know if the simulator has anything to do with it.
So any other suggestions before?
So only one Plinko, there's only one place to drop the Plinko token, or I'm not sure what we should call it. How many paths, how many different ways can it get to each of the prizes?
So when this come out, oops, I am not that good in, I was trying to see whether I can get the arrow. If you know how to use the annotate, maybe you can also draw the arrow down. So from the top, when I put this in, there's 2 opportunity, right? There's 2 chances.
Like 2 different directions it can go.
Either go left or right. Yeah. And you can draw on that too if you like.
Right.
You know what, group? There is a draw feature underneath the line tool. It's called Scribble. And it does a decent job of like kind of tracing out your paths. Yeah, do you see that last one there?
Oh,
So it's kind of
yeah.
like a pencil. It's not as great as so many other tools because you have to reselect it every time you draw a new one. But if you're going to show like the full path down, it's really good for doing things like that.
Okay. Anyone like to try that? Give it a try?
I think because you're the one sharing, you're the only one who can get to that tool right now, correct?
No, I think everyone can try. Yeah. Someone is doing it.
Okay.
And you can pick color too?
Yeah, you can select the colors. So like, for example, I could come in here and say like, this is the way to prize 2, and I'm going to make that one pink.
Ah,
And so you might see all the different ways that it can fall down there.
awesome. Thank you. So this one go here.
And go left, right, left, right. So that gets left, 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 right, right.
Left, right.
That's a clever way of doing it.
See that?
I just took a photo. Okay.
Uh-huh. And
So
then
that's sort of how I see it.
left, then right.
Left, left, left.
What are those trees called? I think of these Mart's Factor trees.
There's my picture. So Lisa,
Tree
mine is
diagram.
like yours, but I
Yes.
just drew a picture.
Yeah. So, oh yes, perfect. So if we look at your picture, I love that. I've got one of those that I did somewhere else. So that shows that we have one way to get to the middle box.
No, there's
Two-
two. Wouldn't there be 2 ways to
and
get to the
one
middle?
for the one for the left and 2 for the middle and 1 for the right. So the probability of each prize would be 25, 50, and 25.
Wait, how come there's 2 ways to get to the middle?
Okay, so if we start at the top,
Oh, maybe there's more.
where no, that looks right. If you go through that little, you're either going when you go left, then you can go to the right, which you see in the picture, or if the first drop is to the right and we slide back to the middle, that shows 2 ways, 2 pathways to get to
This.
that.
So let me draw another arrow.
Maybe.
I will
down.
change that color to red. making
Yeah,
it
that's what I'm
thick.
thinking. We need to do the arrows to show the pathway.
So both blue and red get there, but they're different paths.
almost like if we could make, oh, gosh.
Yes, the blue and red.
I'm clueless on how to do this. Like, yeah, if we could make a combination to get to those two middle ones. I'm afraid if I type here, okay.
And you know
Something
what,
like
Lisa?
that, right?
You can always Control Z it. So if you want to try something on the slide, you're like, wait a minute, what did that do? Pressing Control Z is the undo button, and I wish we had that in real life.
Yeah. So Teresa, just as an off note, we found out that we represent 4 time zones today,
Yes.
No way.
just for fun.
That's so
East-
cool.
Eastern, Central, Mountain, and Pacific. Woo!
What are the chances of that happening?
That's what we said.
Yes, that's what Kathy said.
All right, I'm going to have to bring that up in our discussion.
Isn't that fun? That's so fun.
How fun.
I love it.
Okay, that looks good. Are we ready to go on to slide number 2 of the second one, do y'all think? Do we feel good about it?
Yes.
I love those fractions in the house.
Oh, okay. That's now. How did you get that to a graph?
So on the left-hand side, where at the far left of the screen, there's a little yellow eraser, and then there's some buttons above it, and one of the buttons is a counter, and I clicked on it, and it turned it into a graph.
Okay, got it.
Hi there, group. It's so exciting to see the generator being used, but like it's not perfect for this problem. It's going to require you to like kind of stretch and be flexible to think about the problem. How are you starting to discuss that?
So we were just talking about how, based on like statistics and sample sizes, when you have a bell curve, you're usually going to land in the middle as much as you can.
Right.
And then we haven't started talking about the problem because we're just playing around
With the
with
simulator. We were clicking around the simulator and noticing what happened when we did sample sizes of 100 just to get some trials going, just to see what would happen in that triangle shape so that we could have some generalizations before we tackled the Plinko triangle.
Oh, cool. So what were those generalizations that you started to make?
That they're landing mostly in the center, and that's where Raha brought up like the bell curve and the idea that the majority of like it's not equal probability that they're going to land on all 3 of the slots. Mm-hmm. It'll be most likely centered in the prize 2.
Neat.
Is there a way to edit the bin?
There is. If you go to the lab, there definitely is. If you go to the one with the actual little marbles, I don't know that it.
Yeah, so I was able to
on
do the rows. Yeah.
So if we click on lab, we click.
So here's an example of mine that's going.
Oh, okay.
So you can change it, but the thing is that top piece is still there, so it's not perfect.
Right.
But it should help make some generalizations.
Yeah, that makes sense. Yeah,
So I guess since the majority of the balls end up in the middle, then depending on if you want to give away a big prize or a small prize, you want to give away a big prize, then looking at the one we're on, we make prize 2 the highest. And if you don't want to give away too many big prizes, you'd make prize 2 the smallest.
I agree. Okay, so.
And Colette, on the Plinko game, the actual one, that's kind of what they do. They have 10,000 right smack dab in the middle. But then their next largest prize is halfway between the edge and the middle, and halfway between the middle and the edge. So that's their next biggest prize. And I'm curious if that is what we expect. Is it like always a middle of a middle of a middle, or is it always right in the middle? Why do you think they do what they do?
They also do the thing where they have 0 right next to 10,000
Ah.
because yes, the middle gets the highest, but then the one right next to the middle is the second.
Oh, I see. Like the two that, like the two. So if 1,000 is in the center, then the two surrounding ones are the 0, right?
Mm-hmm.
Right. Well, at least that was in the video. So like you have a high chance of getting the 10,000, but you have a pretty high chance of also getting 0. So depending on how many times you're throwing the coin or the ball down, you will at one point get 10,000, but it really depends on how many times you're throwing the ball down.
Well, if you look at all 3 of our models, in all 3 trials, most of those balls have ended up in that 10,000 or the 2 zeros.
Right.
Right, and there's 2
zeros.
of the slots for zeros, so there are twice as many of those slots than there are of the 10 of that 1,000 slot.
So the chance of walking away with nothing, you've got to basically, if you've only have 3 prizes like what's on our slide right now, then you're looking at a 66 2/3% chance you're going to walk away with nothing.
Right.
Mm-hmm.
Interesting.
That's a really cool generalization. And I wonder if that changes on how many rows there are. Like if there's 5,000 rows, is walking away with 0 more likely? I have no idea. This is a legit question.
That's a good question.
Y'all are on a great roll. I can't wait to see what else comes out of this.
Yes.
So now you have 6, 7, 8 different paths in 4 prizes. So we've gone from 25s and 50s to 12 and a half. So there's and 25s. No, that's not right. 3 out of 8, 37 and a half percent. So 3/8.
Yeah.
Yeah. 2 1/8 and 2 3/8. Right. So if I go back up, there was how many? 1, 2, 3, 4, 5, 6, 7.
I'm really wondering if it's 8 instead of 6.
That's what I'm thinking, that there's more ways to get into the middle part.
Yeah, but like I did, let me put a box and show you what I've got on paper. It's possibilities.
3.
And I'm gonna come over here and put
1, 2.
And then I had
1,
left, right,
4.
and then left, right, left, right, right.
1, 2, 3, 4, 5. 1.
And then right at the top. I'm gonna move it down here.
1, 2, 3.
Left, left,
2.
right,
1, 2,
right,
3.
left.
I think we could have a different color here. 8 possibilities.
I think it's 8. I was
I
messed
just
up on my
I'm
drawing.
looking like
Yeah. So I'm just going to put a big X through this one and say this was a mistake.
Here's our orange, but here's what your drawing does show. Go back and look at the bottom. 1, 2, 3, 4.
I've got 8.
You're missing one little thing. Okay, so on your bottom you've got the left where it says 1 out of 6. And then you've got left, left, right, where it says 2 out of 6, but that's 8 because it would be left, right, left. So, oh no, that was a picture. No, there's something missing. There's some arrows.
I know. It's the stuff in the center that's missing.
Two.
I think for prize number 2, there are 3 different ways to get there, and for prize number 3, there's also 3 different ways to get there, plus one way to get to prize 1, one way to get prize 4.
With the left, right thing, yeah.
Because that left, right lands on prize 2. Ooh, I'm going to put this. Here's what I'm going to put. Prize 1.
Yes.
There should be 3 in the middle.
And then this one, left, right goes to prize 2.
Yes.
And then left, right, left goes to prize 2.
2. Mm-hmm.
And then left, right, left, let's see. Oh.
Goes to prize 3.
Prize 3, okay. If there's 2 lefts, I think it goes to prize 2.
Yes.
And if this is prize 4.
Mm-hmm.
Okay, so 2 rights goes to prize 3.
Mm-hmm.
And 2 lefts goes prize 2.
And 2 rights are prize 3.
Prize 3. So now,
Oh, Lord help us.
I think we're seeing a pattern too.
Yep.
Okay.
What kind of pattern
so
are you starting to notice?
Like the number of possibilities each time as we go down, it's a power of 2. So now we're at 2 to the 3rd power. So the next layer should be 2 to the 4th power, 16 possibilities. And the previous we had 4, 2 to the 2nd power. And when you just put it in, it's left to right. So that's 2 to the 1st power.
So talk to me about this to the powers. What does that mean in terms of the context of the problem? Is that how many Plinko chips you get, or like, what does that really mean?
How many pathways? How many possible pathways?
Cool.
That you could come on any layer as you move down. Okay. Do y'all want this to be in percentages or fractions for our prize? Any preference? We'll go. Oh no, I don't want to do that. Let me pull it over. Okay, where was I?
Well, if I'm a game show host and knowing that the furthest sections, I not as many chances, then I probably want to put the larger prize on the outer edge. But I don't know.
If we don't want to give away money, we want to put the smaller amount. So I don't know. I don't know. We just come on, Miss Lisa, come on. 3, 8. Oops. And then, oh my gosh.
Hello, everyone, and welcome back. I could tell, by the way, everyone was still in their room right up to the end that you all were really engaged in this one. This is a great problem to do. And I love that the simulator isn't a perfect representation of our actual problem because it requires us to kind of think a bit more. All right, so I'm on slide 26. Let me share my screen. Oh, I am. Perfect. Oh, there we go. I'm on slide 26. I like to model every time I do a rich task off of the 5 practices for orchestrating productive mathematics conversations. So during the time that you were in groups, I was monitoring, I was listening in, observing, asking some questions, and really keeping track of stuff. A unique advantage to online learning is I can get a picture of your rough draft thinking, which means I get to really showcase some emerging thinking before it is finally like all shuffled through. I've selected and sequenced some things very purposefully here. And now I'm going to go ahead and connect, and I'm going to try to add in some of the advantages to online learning through this discussion. So I'd love to start off with just group 2. Would you tell us the funny thing that you learned about time zones?
Sure, we can do that. So let me start in the east. Cynthia is in Maine, Eastern. Lisa is in Texas, so Central. I'm in Edmonton, Alberta, Canada, which is just straight north of Montana, so I'm in Mountain. And Amy is in the California Pacific time zone. So we thought that was pretty cool.
The chances of that happening are pretty neat. Very cool. Well, thanks for sharing that. It just kind of goes along with our day unit and activity here. And come on down to slide 27, or you can just follow along with me, either one. And group 1 was having a phenomenal discussion on the fractional pieces. So what I have here are 2 models, and I'd love for if someone from group 1 can just kind of explain to us what your thinking was between the blue model and the yellow model. I know these might not have necessarily come from your group, but the idea of the fractional pieces. What was your group thinking about, and where did you go next?
We were in group 1, but I don't remember having that conversation about fractions. It could be the lack of coffee this morning, but I just don't remember that.
Maybe it was a different group. I'll put this out this way. If you were in a group that originally thought of it in terms of these yellow pieces, these 1 out of 3, would you tell us kind of where that initial thinking was and then where you moved next?
Okay, I'm going to put myself on the line again. I do remember saying 1/3 because there was only 3 choices at the bottom. But then when they were doing the paths, that's when we realized there was way more paths than just 3. There was 3 outcomes, but not necessarily the number of paths.
So there's 3 prizes, but 4 paths. And that's kind of this, oh man, that's a little weird. And I'm curious, Lisa, you made the model, I'm going to put it in with a green arrow here. You made this green model, and I'm wondering if you could show us, like, I see 4 outcomes. Where's the 3 prizes?
The one that has left, right, and the one that has right, left would be the same result. Even though they took a different path, they landed at the same prize 2.
So both of these green arrows is actually, let me do a green outline to this one to try and color code it, with this green piece down here. And
correct.
Yeah, so that's an important thing. We're talking about number of outcomes or number of prizes. And now that we've kind of got that thinking under our belt and we see it 2 different ways, I'm curious if group 2 could share the conversation of, on slide 28, is it 6 or is it 8? And I'm really interested in how that conversation evolved.
Well, we realized, team jump in anytime. We realized that the original drawing with the 6 was incorrect because there were more chances than 2 6. There were more pathways. And so we ended up exploring. We made a chart, I think, with left, right, and all the combinations, which confirmed that there were 8 possible outcomes. So if you go back to our slide, I think we've got that there. And then we put a big, right there, Teresa.
Yep.
And then we ended up exploring exponents, which corroborated our hypothesis that there are 8. So we started using exponents, or I say it differently in Canada, exponents. We corroborated with the 2 to the 0 in our previous slide when we got 1 chance. So 2 to the 0. 2 would be 2 to the first, and then 2 squared and 2 cubed. We started seeing a pattern. So I think that's how we got going. But we knew we were wrong. We were missing something.
So I put on slide 20. I love that you were explaining that. We're going to get into the exponents a little bit more in just a minute. Let's look at slide 28, what Kathy was just mentioning with this left, 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 right, right, left. And I'm curious, from this list, the list that I got the arrow at, can you find the ones that were missing from the colorful arrows? Which ones are new on that list? And as people are analyzing that to find the new ones, Raha, can you make a connection to last week with the combinations? How do you see that here?
So last week on our task, we were trying to find out how we can take different items and combine them in different ways. So this, if we turn like a tree diagram, so if we turn this sideways, that would what I'm envisioning, like that would exactly what this would look like.
Yeah, it would indeed be just like a tree diagram. It connects with last week. And if you're watching the recording, that was Stan the Ice Cream Man last week. So an important thing I always like students, teachers, everyone to consider are the connections between these representations. So we have the colorful arrows and we have the list. And as a group effort, if you see a connection, I've already made the orange one for you. Feel free to add arrows, color code them so that we can see how the list connects to the colored arrows. We got orange and purple done. What I love about this is even if 2 kids are doing the exact same one, like that's okay, right? Everyone can do this. It's completely anonymous. I see someone's finding these extra pieces. If you were the author of the starred arrow, would you tell us where did you see that and when did you see that?
Oh, I don't know if that's going to be fair because that I'm in group 2, and towards the end when we realized that when I was following along with the color arrows, I realized that from this arrow here to this one, I only made one pathway, which is all the way to the left. I forgot that I should split to the other one. So I grabbed another arrow to show that it could split off from prize 1 to the possibility of going to prize 2. So that's when, as I was looking at left, left, right, I realized that was what's missing. Then likewise, I shouldn't say anything else. I'll just talk about left, left, right.
Awesome. Okay, now I'm feeling confident that we have connections between a list model and a visual path model, which is going to be great for when we get into more complicated ones with like a whole bunch of Plinkos, maybe 10,000 Plinko drops. But before we get there, I wanted to engage us in a chat waterfall. So the way that works is you get your chat box, you find that. We all type in at the same time, but you don't hit enter. And then we all hit enter at the exact same time. So on slide 29, I have 2 images that I stole from groups. And I want to know, why is the simulator so vastly different? There's lots of correct answers here. Why is the simulator so vastly different? The simulator's on the left. Put your thoughts in the chat. All right, go ahead and hit enter at any time. And again, there's lots of great reasons why. Raha brought up the one that would have been my objective for the day, so I would have her kind of explain it a little bit more. Raha, what do you mean by a real trial?
So the simulation is me showing what would really happen if this was an actual situation of Price is Right. So if I'm throwing down the balls, I'm sorry, I don't know what type of balls, I'm actually doing the experiment and I'm showing what it would look like in real life, versus the tree diagram is a hypothetical, what we think might happen if we did it. So we're just finding probabilities on the right side, versus on the left side, we're doing it to prove our thinking, if that makes sense.
Yeah.
Our team had another observation, which was kind of cool. When you have an even number of bins, the 2 bins in the middle are your highest probability, versus if you have an odd number of bins, the one right in the middle would be the highest probability. So it made me think of when we did mean, median, and mode, because it's the median of all the bins. Okay, I'm done.
Nice connection to that median when you have 2 in the middle versus an odd. Absolutely, man, we could spend a good amount of time on that one also. Okay, I know some of you all are in upper level math, so I do want to get an opportunity to talk about that. While Lisa is talking, I have a challenge for everybody else. Try to find images that we could put on slide 30 that represents what Lisa is talking about. So Lisa, what is a power of 2, and like, what should I be looking for on the web to have an image?
Oh my goodness. Okay, I think of powers of 2, and Kathy and I started it, and Kathy started doing the work with it. 2 to the 0 power is worth 1. 2 to the first power is 2. 2 to the second power is 4. And we started noticing as we went down the layers of the model that we would increase or double. We could double the possible pathways from layer 1 to layer 2 to layer 3. So images of doubling items would be a great idea. I think about with our 8th graders, I think they study genes in science class. So the splitting of the egg, the fertilized egg, so they can see how that multiplies and creates more and more. I can't even think of the term, but something like that, splitting an atom, I think would work.
Neat. As you all, we're starting to get some images in here. This is looking good. We've got some bunnies splitting, and we can see that 1, 2, 3, 5. And this group, we are running out of time, so I want to be able to showcase what this group actually came up with. They found an image that was really neat. And while you all are searching for images, can the author of this kind of hexagonal triangle tell us, like, what does this represent?
It's Pascal's triangle.
And I'm noticing.
And I made a connection just with the Plinko, like with what's happening every time you add a row on the of pegs on the Plinko board.
So these are the exact same things we were just talking about, right? Like the does it have 8? Does it have 4 possibilities? And so we can see that right there. So we have that 1, 3, 3, 1. All right, folks, that was Pascal's triangle. If you are interested in learning more, that's the key word to look up. Our final thing is just a quick thing to type on the slide. Slide 31. This group can chat while everyone else picks a text box. On slide 31, they said the chance of walking away with nothing is higher than walking away with the big money prize. So somebody from group 3, if you want to kind of explain this while everyone else puts their thoughts in the agree or disagree box. So group 3, can you tell us why you thought walking away with a 0 is more likely than walking away with a 10,000?
Well, I was hoping that Raha or Lisa would explain, or pardon me, Raha or Laura would explain it, but we were talking about how, and I didn't realize this, Raha brought up the fact that next, or maybe it was you, Teresa, that brought up the fact that there are zeros in the 2 columns next to the 10,000. And so we were talking about if we just looked at those 3 columns, and that's where it ended up, that you've got 2 out of 3 chances that it's going to end up in the 0 versus ending in the 10,000, or 66 and 2/3% chance of going in there. So the chance of walking away with nothing is 2/3. The chance of walking away with 10,000 is 1/3 if you're only considering those 3 columns. Now, it's probably not exactly that probability because of all the different routes.
Yeah.
But
so we've got all the different routes. We know the middle is the tallest. But hey, we got 2 zeros and only 1 10,000. Like, ugh, that is kind of a tricky situation. All right, folks, I'm going to let you keep thinking about this one because we are out of time, actually 2 minutes over. So I welcome anyone who has questions to hang on, ask your questions and more. But I think that you got stuff from today's lesson that could work for 3rd graders all the way up through upper middle school. And with Pascal's triangle, you really get into upper level math too. So folks, it's been a pleasure. I'll stay on if you have questions, but happy MATHurdays.
Happy Mother's Day to everyone who have kiddos or puppies or kittens or whatever. So happy Mother's Day, everyone.
Thank you.
Thanks, Teresa.
Oh, you're very welcome.
And thanks for sharing the was it the videos last week when I asked you, like, what the heck are you doing when you're watching people work, and you had shared that, you know, the teachers had gone in and thought about all the possible ways. That helped me really understand sort of a process.
Yeah.
to go through. So thank
you know,
you.
I can't recommend more. The 5 Practices book. Peg Smith, Mary Kay Stein have really done amazing stuff. I have a picture of one of them on slide 26, but they even have them for different grade levels. So if you want one for like high school specific